So I'm going to go through the material cost, the material cost per unit problem that's listed right here. We'll scan down to on this PDF, a material cost problem. So remember this R minus V over N is what we're going to be using. So in this case, I'm defining a batch of 30, and it could be a batch of 1, and I'm just using 30 because it just says that 5 pounds makes 30 widgets. So that's why I chose that. No other reason because, but that it just seemed easier to calculate that way. And so we have the raw material cost is $30 per pound, and there's 5 pounds that make a batch, which is 30 items. So that's $150. And then there's no recycling, so that's 0. Then N is going to be 30, but it says 1 in 4 is bad. So that's going to be 1 minus 25%. So really, like, it's 75% of this value is what N is. So that's 22.5. So then we just take, because there's no V, it's just R over N, so it's 150 divided by 22.5. Now the next part of the problem says, well, how much would the company be willing to spend if the reject rate went down to 1 in 20 from 1 in a quarter, 1 in 4? So I'm just going to recalculate the N value is the only one I need to recalculate. And that means then that if I take 150 divided by this 28.5, I get 526. Now that's the difference in the prices, 667 to 526. So if I take that difference, it's $1.40. And if I have 400 units that I'm saving $1.40 on, that means that I can spend up to $280,000 to try to get better, well, lower scrap rates. And so that's the answer to that problem.